All right, ready to dive in. We're tackling coordinate geometry today.
Coordinate geometry sounds a little dry, maybe.
Yeah, maybe from a textbook, but trust me.
Oh, it's anything but.
Right. We're going to uncover the magic hidden in this chapter. It's not just about, memorizing formulas.
It's about understanding a system that's like the backbone of how we describe, well, location, space, everything, really.
Exactly. And the book starts off really smart, actually. Uses this simple idea. Think about how you'd tell someone to find your friend's house.
Street names, house numbers.
Right. It's basically already coordinates.
Exactly. And from there, the book takes us to this dot on a piece of paper idea.
Oh, yeah. I remember that.
If you want to tell someone exactly where that dot is, you need more than just a description.
Like, it's kind of near the middle. It doesn't really cut it.
Nope, not at all. You need a system, a precise way to say, it's this far from this point and this far from that point.
Which is where our coordinate plane swoops in to save the day.
René Descartes, he's the mastermind behind it all.
Descartes, right? What was his big breakthrough moment?
Well, imagine trying to describe a shape like a circle, just using words. It'd be a mess.
Oh, totally.
So Descartes, he figures out that by putting a grid, what we call the X and Y axis, onto a plane, you can suddenly describe any point on that circle, any point anywhere using just two numbers, its X coordinate and its Y coordinate.
So he turned shapes into numbers.
Precisely. Revolutionized math. And not just for mathematicians, for anyone who deals with, positions and locations.
Okay, now we're talking whoa moments. This is like maps, computer graphics, all that cool stuff.
Absolutely. But before we get ahead of ourselves, let's break down how this system actually works, shall we? Imagine you're back in school, sitting in a classroom.
Oh boy, back to school already.
And think about the seating plan. Each desk has its specific location.
Just like points on our coordinate plane.
You got it.
Rows and columns, just like with our X and Y axis, right?
Exactly. The book calls them, the X-axis and the Y-axis pretty straightforward.
Makes sense.
And they're basically just number lines, right? But the cool part is they intersect.
At that 0, point?
Yeah. The origin, the starting point, and get this, they divide the whole plane into 4 sections.
Quadrants, right. Always sounded kind of mysterious, like 4 different worlds.
Well, they each tell us something important, for sure.
About
The location of a point based on if its coordinates are positive or negative.
Okay, so like a points address, kind of. We've got the X-coordinate telling us how far left or right from the origin, and then the K-coordinate, up or down.
Bingo! You got it. And here's where it gets interesting. The order. It matters.
Order.
Yeah, the book makes this point really clear with an example. I think it was 4, 3 versus 3, 4.
Oh, just flipping the numbers around.
Exactly. Completely changes where you are on the plane.
It's like, It's like how changing the order of words in a sentence changes the meaning. Right.
Perfect analogy.
Like, dog bites man is way different news than man bites dog.
Haha. Exactly. And that's why this system is so powerful, just 2 numbers, but the order makes all the difference.
Like a code, a secret language for the coordinate plane.
You could say that, but it's not really a secret, right? It's everywhere.
Wait, so this isn't just some abstract math thing. I mean, the book hinted at it, but where does this actually come into play in the real world?
Oh, man, are you ready for this? Think about maps. They use coordinates.
Oh, right. Latitude and longitude.
Exactly. Pinpointing locations, and then there's computer graphics.
How does that work?
Every single pixel on your screen
Yeah.
has an X and a Y coordinate, tells the computer where to put it.
So like those "you are here" maps at the mall.
Yeah.
That's coordinates in action, right?
Exactly. Real-life plotting, and the book even walks us through that whole process.
Oh, right. Taking those coordinate pairs and finding their spot on the plane.
And it all comes down to understanding those directions, positive, negative. It's like learning your cardinal directions, but for math.
Right. Instead of north-south, it's which way do these numbers tell me to go?
And once you get that, it's like you see that coordinate plane everywhere.
Hitting grid on the world. Okay, what about that dice game the book mentioned? That seemed kind of cool.
Oh, brilliant way to make this hands-on. You're not just dealing with numbers on paper, you're rolling dice.
Getting your coordinates, moving a piece around, that's way more fun than just plotting points.
Exactly. Brings the whole concept to life.
So we've gone from like finding our friend's house to the secret language of computer graphics.
All thanks to coordinate geometry.
It's amazing how something that seems like just another chapter in a math textbook is actually like the foundation for so much.
It's all about perspective, right? Taking a deep dive, making those connections.
And realizing that math, it's not just formulas and equations. It's the language of how things work, how we describe the world around us.
Absolutely. And hopefully next time our listeners encounter coordinates, whether it's on a map, their phone, or even just thinking about a video game, they'll have a little aha moment.
Remembering that they've taken this deep dive with us, and they know the why behind the what.
Exactly.
This was a fascinating deep dive. I always love uncovering the hidden connections in these seemingly simple math concepts.
Me too. It's a great reminder that math is everywhere, even in the most unexpected places.
And that's a wrap on another deep dive. Thanks for joining us, and we'll see you next time.